In this problem, we will calculate this sum. And the first thing we will do is to create a geometric sum. So our sum is equal to, here we have 4 as a common factor. We have 4 times 1 plus 11 plus 111 plus and here 1 1 1 1 n terms, and it's of course equal to 4 times, here 1 is 9 over 9 plus 11 is 99 over 9 plus this number is 999 over 9, and of course until the last number here is 9999 n terms over 9 and of course it's equal to, here we have 9 as 1 over 9 as a common factor, 1 over 9, so here we have 4 over 9 times, and here we have 9 plus 99 plus, and 9 is 10 minus 1, and of course 99 is 10 squared minus 1 plus this number also is 10 cubed minus 1 plus, and of course the last number is 10 to the power of n minus 1. Here we have gained our geometric sum. So I will continue here. So our sum is equal to here 4 over 9 times 10 plus 10 squared plus until 10 to the power of n. Here we start with the geometric sum, and here we have minus 1 repeated n times. So it's minus 1 times n, which is of course minus n. It's minus n. Now let's continue like this. So we have it's equal to 4 over 9, and here the geometric sum, we have the first term is 10 times, and here the ratio is 10, so 10 to the power of number of terms from 1 to n, it's n minus 1 over 10 minus 1, of course minus n, and here it's equal to, so here we have 4 over 9 times, here we distribute this 10, so it's 10 to the power of n plus 1 minus 10, and here 10 minus 1 is 9, of course minus n, and it's almost done. So it's equal to here 4 over 9, and here the same denominator is 9, so here 10 to the power of n plus 1 minus 10, and here minus 9n minus 9n to get the same denominator. And now we will just write it here. So 9 times 9 is 81. So it's equal to 4 over 81 times 10 to the power of n plus 1 minus 9n minus 10. And of course, this is the result of this sum. And of course, this concludes our problem.